All right, welcome to this explainer. Today, we're going to completely shatter absolutely everything you thought you knew about extreme weather and tornado survival by digging into 7 mind-bending records. Seriously, if you've ever watched a storm chasing clip online and thought to yourself, yeah, I totally grasp how dangerous these systems are, you might want to buckle up. Okay, let's just dive right in by challenging some of your baseline assumptions. See, we often think of tornadoes behaving in somewhat predictable ways, right? Like they follow certain physical laws. But the storms we're unpacking today, they completely rewrote the rule books. By the end of this explainer, you'll see exactly why these specific records still keep veteran meteorologists awake at night, debating the data literally decades later. So, part 1, illusions of speed and size, how physics tricks human reflexes. Let's actually start with something most people don't even factor into their survival plan: forward speed. Normally, tornadoes drift across the landscape at a fairly manageable 25 to 40 miles per hour. Dangerous? Sure, but totally survivable if you have a warning and clear roads. But in June 2014, storm chasers tracking a violent supercell in Pilger, Nebraska, clocked something that broke the rules completely. This tornado was charging forward at a staggering 94 miles per hour. And this right here perfectly illustrates how forward speed completely alters the physics of destruction. On the leading edge of a fast-moving vortex, that 94-mile-per-hour forward momentum stacks directly on top of the rotational wind. It hits with dramatically more force in the backside, flattening homes before they even have a chance to flax. But here's the really terrifying part. The gap between radar detection and impact shrinks to almost nothing. Sirens that normally buy you 8 minutes of escape time, at 94 miles per hour, they buy you less than 2. You can't jog to a neighbor's basement. Honestly, you don't even have time to grab your shoes. Let's move on to our next record and see how this builds, shifting from blinding speed to just terrifying scale. If the Pilger tornado was all about outrunning highway traffic, the May 2013 El Reno tornado was about a width that completely shatters human perception. At its peak, this circulation expanded to an incredible 2.6 miles wide. To put that in perspective, that is roughly 14 times wider than your average violent tornado. Literally wider than Manhattan Island is long. Now, that massive 2.6-mile wedge created a fatal visual trap. Your brain naturally uses size as a stand-in for speed, so a tornado this unbelievably huge looks like it's barely crawling, right up until it's right on top of you. Experienced chasers usually position themselves laterally, just outside a path. But El Reno's rapidly expanding edges swallowed researchers who genuinely believed they were standing in a safe zone. This tragically included the highly experienced TwistX research crew, Tim Samaras, his son Paul, and Carl Jung. They couldn't react in time simply because the storm grew faster than human reflexes even allow. Moving on to part 2, relentless time and space. Basically, anomalies that just shouldn't exist. So, the crucial point here is the sheer, uninterrupted duration plotted on this timeline. Back on March 18, 1925, a tornado touched down in Missouri and did not lift until it reached Indiana, an agonizing 3.5 hours later. It left 219 miles of unbroken devastation. Murfreesboro lost 234 people in minutes, and the small town of Gorham, its entire downtown was wiped completely off the map. To this day, researchers still argue if this was one continuous vortex or a rapid-fire family of tornadoes touching down on the exact same track. Modern models say a single vortex can't possibly hold together that long, but the damage survey showed one unbroken scar. To really wrap your head around this, just picture a tornado dropping down in Manhattan and never lifting, never giving the ground a break until it crosses the border into Maryland. That is the relentless, exhausting scale we are talking about here. Which other scientific theory is right? The people on the ground experienced it as one unending nightmare. Now, if the tri-state record was about how much ground one single storm could cover, our next record is about how many tornadoes the sky can produce at the exact same time. On April 27, 2011, meteorologists were forced to use the word unprecedented over and over again, as more than 200 confirmed tornadoes touched down in a single 24-hour stretch. During what is now known as the 2011 super outbreak, radar screens literally looked broken. Warning systems fell hopelessly behind because there were just way too many signatures lit up at once. This single outbreak spawned four massive EF5s. The Hackleburg Phil Campbell tornado carved a 132-mile path, and the Tuscaloosa Birmingham tornado tore straight through a densely populated corridor. By the time this whole system cleared out, 324 people were dead, leaving $11 billion in damages in its wake. Okay, part 3, breaking the measurement scales. What happens when radar completely contradicts the official rating? On May 3, 1999, Dr. Josh Werman's team was parked near Bridge Creek, Oklahoma. They watched in absolute disbelief as their mobile Doppler radar flashed a number that stopped them cold: 321 miles per hour. They actually checked their equipment 3 separate times because nobody could believe it. I mean, it's wild to think about, but that is faster than a Formula One car at top speed. It's faster than the strongest hurricane ever clocked. At that velocity, wind doesn't knock buildings over, it erases them. Investigators walking the damaged path later couldn't even find foundation outlines, just scraped earth. What's truly fascinating here is looking at the definition of the enhanced Fujita or EF scale. It rates tornadoes strictly by the physical damage they leave behind, not by the real-time wind speeds that Doppler radar captures. So it's a damage-based metric, not a wind speed metric. And this specific definition sets us up for a pretty massive modern contradiction in meteorology. Because the EF scale relies entirely on leftover damage, let's look at the May 2024 Greenfield, Iowa tornado. This storm was measured by 2 separate mobile units at a peak gust of 318 miles per hour, but it only received an official EF4 rating of 185 miles per hour based on the damage indicators. It almost perfectly matched Bridge Creek's wind speed, yet officially it's rated lower. This really exposes a very real crack in how meteorological measurements are classified and recorded today. Finally, part 4, the ultimate toll, the devastating intersection of weather and civilization. When it comes to fatalities, the tri-state tornado's 695 deaths have been America's grim benchmark for a century. But you know what? The deadliest tornado on record didn't happen in the U.S. at all. On April 26, 1989, a tornado in the Maniganj district of Bangladesh killed nearly 1,300 people in under an hour. It is truly staggering to realize that this single event resulted in almost double the tri-state's toll, highlighting a real bias in how weather history is often taught in the West. So, why was that single afternoon so uniquely catastrophic? Well, it was essentially a perfect storm of vulnerabilities. You had extreme population density packed tightly together. The buildings were designed to withstand monsoon rains, which offered absolutely zero protection against tornado force winds, and warning infrastructure, it was almost non existent. When this mile wide tornado carved through the towns of Dolapur and Saturia, people had no alert, no shelter, and no time. Entire densely populated blocks simply ceased to exist. Shifting from human tragedy to sheer financial devastation, we land on our final record. See, devastation doesn't always scale with wind speed. Sometimes it scales purely with what is standing right in the way. On May 22, 2011, an E5 tornado tore directly through the heart of Joplin, Missouri, resulting in an unthinkable damage bill of $2.8 billion. That makes it the costliest tornado in human history. Joplin wasn't the fastest, it wasn't the widest, and it wasn't the deadliest ever recorded, but it racked up this incredible cost because it destroyed vital, critical infrastructure. It hit St. John's Regional Medical Center directly while patients were inside receiving mid-treatment care. It destroyed local schools. It even took out the fire station, meaning first responders who were frantically trying to organize rescue efforts found their own headquarters in ruins. You can rebuild a neighborhood, sure, but a hospital and a fire department destroyed during an active emergency, those losses hit a community in ways that just don't show up cleanly on a balance sheet. As we wrap up this explainer, we've seen a storm that outran highway traffic, a vortex wider than Manhattan, and wind speeds that quite literally rival Formula One cars. Seeing how these anomalies constantly rewrite the rulebooks of speed, scale, and destruction, you really have to look at this final question. What happens when records we thought were completely unbreakable are inevitably broken again? Thank you so much for joining me to unpack this incredible data and keep questioning what you think you know about the sky above you.